Hello, welcome once again to Chemistry Meal. Chemistry Meal is a lovely program designed for lovely people just like you. Today on Chemistry Meal, we are going to look at chemical equilibrium. Subscribe to our YouTube channel at Mathematics Meal 1 and follow us on Facebook at Mathematics and Science Meal. Also follow Engineer Ike Okechukwu on Facebook. Alright, without taking much time, let's begin the business of the day, which is chemical equilibrium. Chemical equilibrium. Now, we used to hear about equilibrium. When we talk about equilibrium, generally we talk about balance. We have equilibrium in physics when we talk about equilibrium of rigid bodies, and then we also talk about equilibrium of bodies in liquid. But as far as chemistry is concerned, when we talk about equilibrium, it is with respect to what? Chemical reaction. Now I want to say that equilibrium is a condition or a state that a reaction needs to attain. Yes, it's a condition that a reaction will attain. So it's not a process, it's a condition that a reaction will attain. So as a reaction is occurring at a certain time, the reaction will now attain to what? Equilibrium. Alright. Now we know that when we have a reaction, for example, I have an arbitrary reaction, A reacting to give me C and D. So when A and B react to give me C and D, we have reactions that are reversible and reactions that are irreversible. This arrow indicates that this reaction is what? Irreversible. That means it cannot proceed in both what? Directions. So here, the reaction is irreversible. That means it can only proceed in one what? Direction. Now, so if I'm talking about the rate of this reaction, I will only be talking about the forward what? Reaction. But if I put another arrow in the reverse direction now this reaction is reversible. So I can talk about the forward reaction and the backward, or the forward and the reverse what? Reaction. Now if a reaction is occurring and that reaction is reversible, as we have seen here, it will get to a point where the rate of reaction of the forward reaction is equal to the rate of reaction of the what? Backward reaction. So when the rate of forward reaction is now equal to the rate of backward reaction, that is the rate at which A and B combines to give us C and D, is also equal to the rate at which this and this are combining to return to A and B. So once that happens, we say that the reaction is now in equilibrium. So let's define chemical equilibrium of a reaction. Okay. Chemical equilibrium of a reaction is a condition or state in the course of the reaction where the rate of forward reaction is equal to the rate of backward reaction. So chemical reaction equilibrium, or chemical equilibrium of a chemical reaction, is a condition or state in the course of the reaction, where the rate of forward reaction is equal to the rate of backward what? Reaction. So if I have a reaction, if I have an arbitrary reaction, let's say I have A, let me still use the reaction I used above there, A plus B, and I have this, then C plus D. Let's say this is the reaction occurring. Now I have the forward reaction, and the backward reaction. The forward reaction will be combination of A and B to give this. The backward is now the reverse. Now if the rate of forward reaction, that's RF, let me use rate of forward reaction, is equal to the rate of backward reaction then that's backward reaction, let me call it RB. Then the reaction is in a state of equilibrium. So like I said from the beginning, that equilibrium is a state, it's a condition. It's a condition. It is a state that a reaction will attain. That means when a reaction starts occurring, it will not be in equilibrium at the beginning of the reaction. So, but after a certain time, that reaction will progress and then attain what? Attain equilibrium. Now, sometimes people confuse themselves with this definition of chemical equilibrium. It's important to note that during equilibrium, the concentration of the product is not necessarily equal to the concentration of the reactant. For example, I have A and B as the reactant, C and D as the product. So this is the reactant. Sorry for the ink. This is the reactant. This is the reactant. These are the reactants, and then we have the products here. Now, during equilibrium, it is the rate of forward reaction that is equal to the rate of backward reaction. It is not the concentration of the reactants that will be equal to the concentration of the product. So don't say, oh, because the rate of forward reaction is equal to the rate of backward reaction, because of that, their concentrations will be equal. No, it's not true. The concentrations of the forward of the reactants will not necessarily be equal to the concentration of the of the product. Very important, very important. But another thing we need to note is that there will be no change in the amount of of the reactants and the product. So once a reaction attains equilibrium, there will be no change in the amount of concentration of the product and also concentration of the reactant. That means the concentration of the product will not be changing, and the concentration of the reactant will not also be changing, but the two concentrations are not they are not equal. It's better that we look at the characteristics of a reaction in equilibrium. So let's quickly look at that. Characteristics of a chemical reaction in equilibrium. So characteristics or properties of a chemical reaction in equilibrium. Okay. So number one characteristic is that for a reaction to be in equilibrium, the reaction must be reversible. That means it's only reversible reactions that can attain equilibrium. So number one, the reaction must be reversible. That's number one. The reaction will be able to proceed in both directions. So if the reaction is irreversible, then the reaction cannot attain equilibrium. Number two, there is no net change in the concentration of the reactants and products. So the concentration of reactants remain constant. The concentration of products also remain constant. But that does not mean that the concentration of reactant is equal to concentration of product. Have that at the back of your mind. The two concentrations are not equal. It's just that the concentration of the product is no longer changing, and the concentration of the reactant will not also change. Will not also change. Okay. We have so many characteristics. Catalyst has no effect on a system in equilibrium. So once a system is already in equilibrium, introducing a catalyst will not have any effect in the reaction. So catalyst has no effect on a system that is already in what? Equilibrium. Before a system attains equilibrium, before a system reaches equilibrium, if you introduce catalyst, the only thing the catalyst will do is to help the system to attain equilibrium faster. But once a system is already in a state of equilibrium, then introducing a catalyst will be a waste of time, because that catalyst will not affect a system in equilibrium. So another characteristic is that Gibbs free energy change is 0. So when a reaction is in equilibrium, the standard Gibbs free energy will always be what? Be 0. In other words, we know what Gibbs free energy is. You remember that change in Gibbs free energy is equal to change in enthalpy minus temperature times change in what? In entropy. That's enthalpy minus quantity of heat. So when reaction is in equilibrium, Gibbs free energy change is equal to what? 0. And if delta G is 0, that's Gibbs free energy is 0, it means that at equilibrium the enthalpy change is equal to the what? The quantity of heat also. That's enthalpy change. This and this will be equal when a reaction is now in equilibrium. There are so many characteristics. We can also say that the reaction must occur in a closed system where there is no loss or gain in matter or mass. So the reaction will occur in a closed system where there is no loss or gain of what? Of matter. Okay, I can still give more. Okay, let's see more of the characteristics of a reaction in equilibrium. Let's see more of the characteristics. We can also use the definition we gave. When a reaction is in equilibrium, the rate of forward reaction will be equal to the rate of backward reaction. So the rate of forward reaction will be equal to the rate of what? Of backward reaction. That means the system is also dynamic. Dynamic in nature, in the sense that the rate at which the reaction moves in the forward direction is also equal to the rate at which it moves in the backward reaction. So the system is dynamic. Now there is another characteristic that when we look at the law of mass action by wage and go back, we are going to see that characteristics, and that's the concept of equilibrium constant. Now the quotient of the concentrations in a system that is in equilibrium is constant. The quotient is constant. So the ratio of the concentration of the product to the ratio of the concentration of the what? Reactant will give us a quantity we call the what? Equilibrium constant, and it's actually constant for a particular reaction. But I think that these seven characteristics, they are okay. They are okay. All right. That's where we're going to end the first part of the concept of chemical equilibrium. In part 2 of chemical equilibrium, our business will be to look at the law that we use in explaining factors that affect what? Chemical equilibrium. Yes, there are factors that can affect a reaction that is already in equilibrium. There are, even though catalyst is not one of them. We said that catalyst cannot affect a reaction that is already in equilibrium. So we are going to look at a principle we call Le Chatelier's principle, and we are going to use that principle to see the effect of various factors on a system that is in equilibrium. Thank you for watching our video. Remember, in this video you have been able to understand the meaning of chemical equilibrium, and also you now know some of the characteristics of a reaction that is in equilibrium. See you in our next video, where we'll be looking at Le Chatelier's principle. Thank you, and God bless you.